So hello and welcome to this Blockdaemon hosted fireside webinar with Jakob Pagter, the VP of Engineering for Wallet at Blockdaemon, on the role of MPC and threshold cryptography in Web3 wallets. Jakob leads Blockdaemon's initiatives in implementing multi-party computation, also known as MPC, wallets and vaults to protect digital assets. Jakob has more than 20 years of experience in applying MPC to real-world problems. Jakob was formerly the head of the security lab at the Danish Research Institute, Alexandra Institutet, and is the co-founder of Partisia and Sepior, which was acquired by Blockdaemon. He holds a PhD in computer science from Aarhus University and is a member of the Danish Council for IT Security, as well as the Committee for IT Security at the Confederation of Danish Industry. So, Jakob, you're very welcome to this webinar. To kick things off, could you give us your own expert opinion on the current state of the Web3 wallet landscape today, particularly from an MPC perspective, and which factor, usability, security, or cost, most holds back wider adoption of standard Web3 wallets and why?
Thank you, Connor, and thank you for the nice intro. I think when we started doing MPC-based key management maybe 10 years ago in Sepia, it was a really hard time finding traction. But today, it seems that everybody wants to use MPC in their wallets. But I think if we look at the market today, it's still very much early days. There are a lot of providers using MPC, big providers, small providers. But I don't think we've yet come to a clear consensus on how to do it best. Different providers doing it different ways, which also comes through all of the flexibility for how to do key management using MPC. In terms of maybe what's holding back adoption, I think a couple of things are maybe holding back wider adoption. I think for sure usability, but I think that's one of the areas where MPC can really, help kick off things because it gives you flexibility in terms of designing the application without compromising security. Other things holding back adoption are things like compliance, regulation, and whatnot, which is also the case for the Web3 space in general.
And to give a bit of context, Jakob, the millionaire's problem is often cited as an example of MPC. And to maybe help understand MPC a bit better, could you briefly explain this example that's quite often given? But then could you bridge that analogy to real world Web3 scenarios? Specifically, how do MPC protocols ensure privacy and correctness across decentralized applications?
I can try. So the millionaire's problem is really it's famous from Andy Au's paper back in the day when he introduced MPC, multi-party computation, and it's really about the original problem is about two millionaires, and they want to find out who's richer, but they don't want to reveal to the other person how rich they really are. They just want to get one bit out of the of information, namely the indicator of who's richer, one or the other. So with MPC, you can do such a computation where each party will input, or each millionaire in this case, will input his wealth into the computation, and then using an MPC protocol, a distributed protocol that both parties will participate in, they will arrive at the result about which number is bigger, but it won't reveal any information about the underlying numbers. In general, for Web3, there's a nice fit between MPC and decentralized technology because it's about splitting out trust and responsibility across a number of parties. So there's kind of a natural fit. But other than that, there's also kind of, in particular for key management, there's also the case where MPC, as we'll maybe talk about later, very nicely fits into technologies which have been built into stuff like Bitcoin from the outset, like multi-sig and things like that.
And you mentioned there in your answer, Jakob, that MPC helps split trust amongst a number of distributed parties. And in a practical sense, that comes from splitting a private key into multiple key shares, which is often described as eliminating single points of failure. But could you give us a bit more detail around how this works in practice and why it provides a stronger security foundation for digital asset management?
Yeah, so first and foremost, when you have a crypto wallet, from a security point of view, the key thing is protecting the private key, which is what you use to sign transactions. And as you say, when you split that up, you get a better security model. The key thing to note here is that when people talk about it, also, and I mean, when we talk about it, we say that we take the private key and then we split it into different key shares. But that's not really true. It was never combined. It never existed, right? So an important point about doing MPC is actually when you generate the key, you generate it as something which is inherently distributed. So the entire key never exists. Each party in the MPC computation, each MPC node will hold one key share, which reveals nothing about the full key. So that means that throughout the usage of this key, it never really exists, right? And that's the strength of the key model. And that's how we eliminate the single point of failure or the single point of trust from the outset. Um, yeah.
And then building on this concept, Jakob, I'd like to touch on threshold cryptography, specifically in the context of MPC, and how it enables key management through secret shared keys. Could you briefly explain what threshold cryptography is, and then what unique security advantages does it bring to managing digital asset keys?
Yeah, I mean, threshold security is really, I mean, you take a distributed key. Let's say you have three shares, and then you can define a threshold when you generate it, which is the number of shares you need to have access to execute the signing protocol. So you could say, in general, you say N and T, but it could be maybe if you have five shares, then you can say the threshold is three, or you can say the threshold is all of them, right? So you can kind of, there's some flexibility in the underlying math. That's why it's called threshold security. So what it does from a security point of view, when it removes a single point of failure, is actually it's an implementation of some very old school security principles. I mean, you may have heard of things like four eyes control or segregation of duties. So it's really about not relying on a single entity when executing a security sensitive operation. And the key when using threshold cryptography or MPC is that you get this policy, this four eyes control, or this quora, or this segregation of duties. You get it with a cryptographic guarantee that this is what happened, right? It's not like there's some manual thing involved to guarantee it. It's actually cryptographically, mathematically guaranteed that you have these policy properties.
And you mentioned there that there could be a number of parties involved in a valid signature, three, five, um, I suppose a non-trivial amount of potential parties involved. My question then is, when choosing how many shares to create, how how many are needed for a valid signature, but what operational or strategic factors matter most for institutions when choosing how many signatures they should have in a given transaction?
Yeah, I guess there are two things to say about this question. The first thing is that from a practical perspective, if it's an organization having all the key shards within their own, like a custodial wallet, they want to split it across a number of different, say, organizational entities. But obviously, they don't want to have that number too high because it incurs an increased cost of managing each of those, right? So we typically see two or three as the number that people are using. Another model where you have kind of split custody, a split trust, or how you want to frame it, uh, would be where you have a wallet provider which will hold some of the key shares, and then the customer on a mobile device or laptop or in a secure device, another secure device will hold their key shares. So you can also architect the solution not only by how many shares they are, but also by who controls them.
And you mentioned there are quite a few different setups that are potentially available to institutions. But when it comes to distributing computation across multiple parties, could you touch on, are there potential performance bottlenecks, and how do solutions address latency or scalability concerns at an enterprise level?
There are, I mean, MPC is a distributed protocol. It's advanced math implemented through a number of rounds of communication between the different parties. So in theory, I mean, there can be performance bottlenecks. Our experience in working with this is that as long as you know a bit about the architecture and the kind of non-functional requirements in the application, you can typically tailor the MPC to actually meet the requirements that are there. I don't think I'm aware of any, except for maybe one example. I'm not aware of any where performance has been a serious problem in designing the application. You're on mute.
Thank you. And threshold wallets, Jakob, emphasize what you see is what you sign. Just quite briefly, could you explain what that means? And then in the distributed signing process, how does this work to prevent, fraud, and why is it crucial for institutional trust?
Yeah, I mean, in this is actually not about the wallets per se, but blind signing is a serious problem when you do cryptographic signing. So you have a cryptographic key and you want to sign a message or transaction in this case, and the one holding the key needs to be assured that it's actually the right transaction that's being signed. So when you're doing, say, building an MPC-based wallet, what you see is what you sign is also about making sure that in the architecture, you don't introduce single points of failure um, in other places. Um, for instance, when you're enforcing policies, right? So
And
in this case, you want to have a mapping there. Yeah.
and in terms of that mapping, then, Jakob, in your experience, how do organizations integrate MPC-based signing into broader governance processes? So, for example, requiring multiple approvals for high-value transactions versus potentially less approvals for lower-value transactions.
Yeah, they typically do that by introducing policies, right? So if it's a high value transaction, there's going to be a policy which will require a quora, a subset of assigned employees to approve the transaction, which can be done through a mobile app or whatnot. And what I was trying to say before is that we've seen many cases where this policy enforcement is really it's a choke point, right, in the application. And when you say it's a choke point, it unless you think carefully about it, it really becomes a single point of failure, right? Because the policy enforced by one entity typically, and then you have this nice distributed system on top, which will do the signing. But in effect, that layer will be doing the blind signing when you do the policy enforcement, right? Because the policy engine will check and say this is okay, and then the MPC layer will sign. In our case, what we've done in our wallet products is that we built these two layers together so that we actually get the same threshold distributed property in the policy enforcement. And that's really crucial when you're doing this type of high value transactions.
I'd like to shift gears then into cold storage, Jakob. Specifically, uh, traditionally, cold storage has relied on air gap devices or HSMs. Um, I suppose what should businesses be aware of when adding MPC or threshold-based solutions into cold wallet setups, and how do you mitigate any difficulties that may be encountered?
Yeah, so two things to say to that. The first thing is, of course, again, when you have cold storage, you want to have very high security. You want to have something that's very cold. And one way to make a cold wallet even colder is to implement a four eyes or control on top of the cold wallet itself, meaning that you have multiple cold wallets that need to sign. And this can be achieved using MPC. Um, of course, you need to be careful because as I said, MPC is a distributed protocol that requires the MPC nodes to communicate. And when you're doing cold wallets, actually a cold wallet is something which is not able to communicate over a network. So how do you get these things to match? And in that case, you really need to go in and look at the underlying math and tweak the protocols to do so-called partial signing or offline signing in the MPC protocol, which is also possible, but it's something that takes careful tailoring of the MPC protocol, but also careful tailoring of the application using the MPC protocol.
And when it comes to trusted execution environments or TEEs, how can they improve threshold MPC security and what hardware trade-offs should institutions be aware of?
Yeah, trusted execution environments ensures different things. In particular, it ensures integrity of the program being executed, and it also ensures that it's hard for an attacker to get access to the data being used by that program. Um, so that is something which in some cases there can be trusted execution environments in some cases have some challenges with what's known as side channel attacks. But in that case, distributing it across multiple TEs using MPC is actually the perfect cure for that type of problem. But on top of that, trusted execution environments are very nice when combined with MPC because they achieve security in two very fundamentally different ways, meaning that it's a really strong way of achieving what's known as defense in depth, which is critical when you build a security posture.
And looking ahead, Jakob, which new standards or regulatory shifts will most influence MPC-based wallets for major institutions, and what developments in the MPC space should customers be aware of, or are you most excited about today?
Yeah, I think that like that two things. One thing is how the notion of custody is defined by regulatory authorities in different domains in terms of how it's mapped to MPC. We see sometimes that it's MPC is new technology, so there's some understanding about how it fits into the framework. So that's something where I expect there will be some kind of development. Another thing is the area of validation of the cryptographic modules. For many years, one of the kind of the golden standard for validation has been the FIPS 140 certification. And I know that FIPS have a particular program looking at how to standardize MPC, and I'm expecting over time this will mean that there will be avenues to get MPC-specific validation of cryptographic primitives.
That's great, Jakob. I appreciate the insights today, and many thanks to all of you for joining. The full recording of this webinar will be available shortly on the Blockdaemon YouTube channel. But for any updates and any more information, please visit blockdaemon.com for a full overview of our MPC-based suite of products and services. But Jakob, many thanks for your valuable
Thanks, Connor.
insights and appreciate the time. Thank you.